So here we are doing Algebra 2, L4, Divide Polynomials using long division. It's going to be like every other IXL. It's going to start off pretty easy. And we're going to write this vertical to some degree so you can see what's going on. We've got a negative w minus 8 divided by w plus 8. And that's how it appears vertically. This says do long division. Honestly, I wouldn't do this doing long division, but maybe they want you to so you understand what's going on. That's how you think about it vertically. We're dividing by w plus 8. That goes out what we actually call the vinculum. Some people call it a shed, lots of people call it other things. And we're dividing a negative w minus 8. Now the deal here is how do you turn a w into a negative w? Well, you do that by multiplying by a negative 1. And then you distribute to both terms, okay? That's what throws a lot of kids off in the beginning when they're learning long division of polynomials. You distribute to both terms. If you do that, you get negative w minus 8 again. Now you're supposed to subtract this line. That's what you're supposed to do. Subtraction changes signs. Plus, plus, plus. So we have no w's and we have 0. So the answer must be negative 1. I wish I could actually write that in there. Can I? Incomplete answer, that's what I thought. Surely there's a way to do this. I'm still kind of new at this stuff. I guess I have to type it. Negative 1. Excellent. All right, this one's going to be a little rougher. This is 4r squared plus 28r divided by r plus 7. R plus 7 outside of the shed or the house. I don't even remember what I was taught when I was a kid, but that was long division, man. That was over 30 years ago, 34 years ago maybe. It's been a minute. The deal here is how do I turn this r into 4r squared? Well, I do that by multiplying by 4r. I like to make things line up to r's above r's and so forth. If I distribute, I'll have 4r squared plus 28r. And remember, we're going to subtract this line. Okay? That's going to change that to a negative. That's going to change that to a negative. Now it's back to a positive. Add down, and we have nothing left. So the correct answer is going to be 4r. I have no idea how hard IXL is going to make these. My guess is, as an Algebra 2 teacher, it's not going to be hard enough. It's still easy. This one actually has a remainder, so it got a little bit harder. I don't know what group jam is. I just noticed that. Dividing by p minus 7 goes outside. And on the interior, negative 2p plus 22. And by the way, I can kind of glance this and tell you that the quotient up top above the vinculum is going to be negative 2. And we're going to have a remainder of probably 1 piece of something. So let's see what we get. Turn a p into a negative 2p, we multiply by a negative 2. If we distribute to both terms, we'll have negative 2p plus 14. I don't know why I said 1. Obviously not 1. I'm going to subtract this line. It makes that positive, makes that negative. Now I'm going to use addition. Adding down now, I see that I have a remainder of 8. And you cannot turn a p into an 8 using positive exponents. If that doesn't make sense to you, it's because you haven't got to that lesson yet in Algebra 2. But this is my remainder. This should be written out as negative 2 plus 8 pieces of p minus 7. At least that's how I teach my kids to do it. Hopefully IXL is the same. We'll find out. They've got the fraction key there, so that's a good sign. It's always remainder over the dividend. Or divisor, sorry, not dividend, the divisor. So that wasn't too bad. We're at 37 now. Maybe it's starting to get difficult, maybe not. I haven't seen any need for placeholders yet, so that's nice. Oh, here, will be to take that r right there and turn it into a 15r squared, which is done by doing a 15r. And when we do that, we'll have 15r squared take away 80r. No, sorry, 90r. So this one's actually going to have two pieces up here in the quotient, which is kind of cool. Subtract, that changes that to a negative, that to a positive. Now I get to use addition. So I can add down. I'm going to have 4r, and then just like it was in 5th grade, I'm going to bring down this negative 66. Remember doing long division a long time ago? Now I have a new goal compared to the last couple of them. I'm going to turn this r into a 4r, and I do it by multiplying by 4. When I distribute that 4, I'll get 4r minus 24. Rapid change, addition. Now negative 66 plus 24, it has been a long day, but is that not 42? Negative 42 with that? And this is my remainder. So plus, or actually not plus, minus 42 pieces of r minus 6. Assuming I didn't make a mistake, and it's very easy to make mistakes in long division. Let's find out. Oops, 15r plus 4. I almost made a mistake on typing it in. Don't you hate it when that happens? I know a lot of people just don't like IXL because it's so unforgiving. As long as you're not cheating with Photomath or Mathway, it's a good way to learn. Super. I mean, I've been doing this for years and I still make mistakes. It's about repetition. The more you repeat, the less likely you are to make mistakes. I like this one. This one's probably going to have at least 3 things in the quotient. That's kind of nice. So it is getting harder. I'm glad of that. We're dividing by u minus 2. 3u cubed minus 14u squared plus 16u. We might have to add in plus 0. We'll see. If we need to bring a number down, we'll do it. Turning u into 3u cubed multiplied by 3u squared. That'll give me 3u cubed. Don't forget about the distributive property of that negative 2. Minus 6u squared. Again, I'm a big fan of teaching kids to wrap before they subtract. Just to remind them to make the sign changes. We add down, there are no u cubes, there are a negative 8u squared. It's always that 5th grade skill about adding negatives. It just throws kids off. We carry down our 16u. I'm sorry about my handwriting. It is what it is. The math is good though. Now I want to turn this u right here into negative 8u squared. I do that by multiplying by a negative 8u. And then I invoke my distributive property again. Negative 8u squared plus 16u. This is kind of nice. This worked out beautifully. Because after I change my signs and change it from subtraction to addition, I'll notice I have a remainder of 0. That is literally my remainder. My remainder is 0. It turns out that u minus 2 is actually a factor of the given trinomial. So all I got to keep is the quotient, 3u squared minus 8u. I know if I had a smartphone, I could just write this in place and it would take it, but I haven't figured out how to do that in a PC yet. It's probably under teacher tools. All right. More division. We're at 55. I'm going to bump up. I notice there's a lot of levels here, and I don't want to do this all day. This is level 4 of 7. I don't know how it is at your school. Most teachers here, they want kids to go to 80. I would probably take this thing out to a 90, but I'll know when I see the levels. If the levels are getting harder, then obviously it will escalate. I'm going to introduce a placeholder on this one. I notice that there are no w squared, so I'm going to put plus 0 w squared here. I need a placeholder. Don't have to have it, but it's nice. If I need to say plus a 0, I'm going to throw it there just in case. You need this standard form, decreasing exponents. The goal is to turn a w into a negative 2w squared, w cubed. That is done by multiplying by a negative 2w squared. That'll generate a negative 2w cubed minus 6w squared when I distribute. Change my signs so I can do the addition. There are no w cubed, there are 6w squares. Now I'm going to bring down the 18w. To turn a w into a 6w squared, I multiply by 6w. I invoke the distributive property, 6w cubed plus 8. Oh, that's beautiful. Beautiful. Because when I do the subtraction here, there's nothing. So I thought this was getting harder. It's not. Turns out w plus 3 was a factor. I would realize that if I would have done this lesson properly. They are giving you things that factor. Why are they doing this? I guess because they don't want it to be too rough on kids. And some kids can't factor. Excellent. Let's go up a level. Level 5. Doesn't look any different. We got 4 terms here. Big deal. Once you've done, 7 or 8 of these, they're all pretty much the same. As a young kid doing this, the issue is going to be adding and subtracting. If you've got to use technology to do it, then I guess you've got to use a calculator. I wish you wouldn't, because once you use those calculators, you almost have to keep using those calculators. So I'm going to turn this y minus 10 into a negative 2y cubed by multiplying by a positive 2y squared. That's going to give me, sorry, not positive. I want it to be negative, don't I? By a negative 2y squared. It's going to give me negative 2y cubed minus 20y squared. Remember to wrap before you subtract. Change your signs to make an addition, because you'll have fewer mistakes with addition than you will with subtraction. That's a given. We'll have 26y squared here. We're going to have to carry down that 158y. Now we're going to turn y into 26y squared by multiplying by a 26y. That'll give me 26y squared minus 260y. Man, these things are getting big, aren't they? Things like this make me want to stop and make sure I'm not making any mistakes, and I did. I did make a mistake. Do you see my mistake? I believe that's the eraser. My mistake was right there. I was probably even telling you about where mistakes were made when I did it. So subconsciously, I probably made the mistake. So when I distribute this negative 2, I'd have negative 2y cubed plus 20y squared. There's where the mistake was. I should have gotten negative 14y squared here. That has to be erased. I multiply by a negative 14. By the way, carry down the 158y. Now I'm going to multiply by a negative 14, negative 14y squared plus 140. I like that that's plus 140y. Because now when I add down, this thing's getting smaller here. There's 14, right? 150, sorry, not 14, 18. 158y minus 140y is 18y. Bring down my negative 175. I know this is taught in Algebra 2. In pre-calculus, we use define asymptotes. It deals with what's called horizontal asymptote and slant asymptotes, sometimes called oblique. And then the curves, the quadratics and things like that, it finds asymptotes. It has its place. It deals with long-run behavior of graphs, which is calculus intensions. So if you're a math kind of person, it's kind of a big deal. Turn a y into an 18y, we multiply by 18. That's going to give us 18y minus 180. So I'm wrapping before I subtract, change my signs, make it addition. I've got a 5 left over, and I am done. That is my remainder. So negative 2y squared minus 14y, forgot that y there, plus 18. Hope I didn't make a mistake. If I did, I did. It's easy to do, especially when you've been teaching all day long on 3 hours of sleep. Need my remainder, don't I? Almost left it off. Plus 5 pieces, that's how I say it, some people say it different, of y minus 10. Terrific, thank God, right? Whew. That could have been bad. I'm going to jump up to level 7. And I don't think it actually got any difficult. You know, if I was a teacher assigning this, I would probably make kids do this to a 90 because I haven't seen anything really where they did anything tricky. So if I was teaching this, I would take this to a 90 for my Algebra 2 kids, maybe a 95 if you're what we call honors. But after you do this a couple, 7, 8 times, you want to have it. If you're not one of my students, like I said, I apologize for my handwriting. It's not the best. It's not the worst. All right, to turn a 9q into a negative 18q cubed, we're going to multiply by a negative 2q. That's going to generate negative 18q cubed minus 10q. Ooh, it was a little bit different, wasn't it? Let me erase that. Did you notice that I put that in the wrong spot? Kind of getting the habit of doing things here. Actually, I said something and didn't do it. It's about time for me to stop. I need a square there. That was my mistake. So minus 10q squared. Wrap before you subtract, change your signs, make it addition. Adding down, there are 72 cube squareds, and then plus 40 cube. Now, to turn a 9 into a 72, seems like I learned in 4th grade that took an 8. Seems like 8 times 9 was 72. So we're going to multiply by an 8 cubed because we also need the q squared. That's going to give me 72 q squared. And look at this, it worked out. Plus 40q. You know, once you subtract that line, your remainder is 0. So negative 2q squared plus 8q. If I had enough time to do this, I would gladly take this to 100. But sadly, I'm a dad. I don't mean that. That's just me kidding. I'm a dad. I have 2 kids that I love, and I got to go pick them up. So there we go. 94, pretty good. I hope that helped you. By all means, subscribe to me so that eventually I can get paid for this. I'm no math BFF. I'm not near as good looking, but I know what I'm doing.